want to discuss more on now homologous series. Homologous series. Right. So we want to start with alkanes. Alkanes now. Right. In our last lecture, right, we managed to draw the different homologous series, the alkanes, the alkanes, right? So we want to go into detail with the alkanes, right? So I'm sure you know we've got different types of alkanes. We've got methane. This is our first alkane, right? Methane, it's CH6. Remember, we said the general formula is C. If there is one carbon, it means our hydrogen, we are going to say 2N plus 2. So you see here there is 1. So it's 2 times what? Right? For the, we are saying it's what? C, for methane is CH4, right? So it's 2N plus 2. So it's 1 times 2, right? 1 times 2 is 2 plus 2. So it's CH4. And then the next one is ethane. Ethane, now if there are 2 carbon atoms, it means the hydrogen is 2 times 2, 4 plus 2, that's 6, right? That is for ethane. And then propane, right? We are talking of alkanes, the one that ends with A-N-E, right? So propane, we are saying propane, it has got 3 carbon atoms. So if there are 3, it means the hydrogen from our general formula is 3 times 2, that's 6, plus 2, 8. So it means it's 8. And then we go to butane. So you see the way we are doing, we are using the prefix, right? We are saying number of carbon atoms, right? And then the prefix. So if there is 1 carbon atom, we talk of what? Me. Right? 2 ethe, right? 3 prope, you see. 4 bute, like in mathematics. Like 5, you know, it's what? Like pentagon. You understand? It's pent, right? 6, it means hex in maths, right? 7, it's a hepta, so it's hept, right? And then 8, it's octagon. You understand? 8, and then that's the number of carbons. It determines the prefix. The number of carbons, they determine the prefix, right, in the name. So from there, we are now saying butane. It's now C4. I'm sure you are now understanding the trend. H10. And then from butane, we talk of pentane. Pentane, we are saying the carbons, they are 5. Right? So it means the hydrogen is going to be 2 times 5, that's 10, plus 2, that's going to be what? 12. That's pentane. And then let's go to the hex. We say hexagon is 6. So hexane. Hexane, it's 6. The carbon is 6. So the hydrogen is going to be 6 times 2, that's 12, plus 2, 14. And then the heptane. Heptane. Right? Heptane. We say hept is 7. So it's 7 times 2. 14 plus 2 is what? 16. And then we talk of the octane. You see, octane, we are saying it's C. Right? C8. So it's going, the hydrogen now, 2 times 8, 16 plus 2. The hydrogen is going to be what? 18. Right? So this is like our list of 1, 2, 3, 4, 5, 6, 7, 8 alkanes. So you have to be able to draw all the structural formulas, and you have to know that when we are talking of the characteristics, they are non-polar. These are non-polar because, you know, they contain only carbon and hydrogen atoms. You see, they only have carbon, hydrogen, carbon, hydrogen. They contain carbon and hydrogen atoms only. Carbon and hydrogen atoms, they are hydrobonds. We say they are alkanes are hydrobonds. Hydrocarbons with single one bond altogether between the carbon atoms. One bond between the carbon atoms. Is it clear? Right. So we are saying no further atoms can be added. No further atoms can be added to the molecule. No further atoms can be added to the molecule. I'm sure by now in chemistry you know what an atom is, what a molecule is. The molecules, they form through covalent bonding. Right, so we are saying these are saturated hydrocarbons. Right, so this makes alkanes, if something is saturated, it means it cannot take anything more. So we say alkanes, they are quite unreactive because they are saturated, so there is no way they can take more. So we are saying, although the chemical properties of all alkenes are very similar, they are physical properties. So we are saying the chemical properties, right? The chemical properties are the same, but the physical properties, they vary of alkenes, right? So we are saying alkenes are the most, when we are talking, they are the most important fuels. They are the most important fuels or fossil fuels. These are alkanes, right? And then we are saying each consecutive member of the homologous is an added CH2 group. It has got what? Another way of writing these long chain alkenes is by showing the number of CH groups. For example, octane. Octane, we can also write octane as what? CH3, and then we say CH2, right? CH3. You see, again, there is octane when we are saying 1, 2, 3, right? We are saying for octane, we are going to get, and then the 2 is 6. So it means 6, 7, 8. So it's another way. So we are saying all the formulas for these molecules, they actually fit the general formula CnH, like what I've H2n plus 2. Right. So you have to be able to also draw the structural formula, right? So now if it is methane, it's easy. It's CH4, right? CH4. So to draw it, you just draw 1, 2, 3, 4. H, 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 H. And then if it is ethane, right, it means it's now C, C, right? So it means the C is now, they are what? They are bonded to 3 hydrogen, and this one is also bonded to what? Hydrogen, hydrogen, hydrogen. I'm sure you are quite seeing the way I'm drawing it. Right, so that's for ethane. And then when we are talking of, let's now draw for propane, this one, with 3, right? Propane, C3H8. So we are saying the carbons 1, 2, 3. So they are bonded together, and again they form further bonds with hydrogen. You see 1, 2, 3, 4, 5, 6, 7, 8. C3H8. So these are alkenes. So you have to understand, alkenes, we said they are non-polar molecules. They only contain carbon and hydrogen molecules, and they are saturated. They cannot take another atom, right? The chemical properties are the same, but the physical properties, they can vary, right? They contain only a single bond and are used as fuels.